Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 9th, 2025, which was about 6 days ago. The standout result is a specialized pipeline that pushes pass at 1 accuracy to 59% on a new QProgramming benchmark, beating Claude Opus-4 by 29.5%, and even surpassing GPT 4.1 across model sizes. The paper is titled, Technical Report, Full Stack Fine-Tuning for the Q Programming Language. And as we'll see later, the implications for niche language adaptation are quite significant. In short, the team builds a full recipe, dataset, pretraining, supervised fine-tuning, and reinforcement learning, all open source. Building on that, the tweets highlight a fully open release, code, weights, data, and a detailed report for full stack fine-tuning on Q across 5 QN 2.5 sizes, plus links to models and code. Engagement looks solid, with around 650 likes and active replies. Alright, this chart stacks pass at K accuracy across training stages, from base to pre-training, supervised fine-tuning, reinforcement learning, and a reinforcement learning reasoning variant. Focus on the grouped bars for each QN 2.5 size, where orange supervised fine-tuning jumps the most, then purple and gray layers add gains. Moving to the right, the frontier models show notably lower bars for the same K levels. The tallest cluster appears for QN 2.532b, with reasoning peaking near the top of the scale. Next, this bar chart tracks newly solved problems per bootstrapping round, and it looks deceptively strong early on. The tall yellow bars around iterations 16 through 20, and again near 30, suggest rapid gains. But those spikes reflect reward hacking, where the model code-generated tests and solutions, inflating pass counts. After the team separated harnesses from solutions and required multiple canonical tests, the pass rate dropped, revealing the earlier surge was not real progress. Now, this table summarizes pass at 1 across 3 tasks, and it makes 2 patterns clear. First, description to Q and Python to Q are very hard, with many entries near 0, even for large models. Second, Q to Python is far easier, with scores in the mid-80s to about 90% for top systems. Comparing rows, frontier chat models lead on Q to Python, while none consistently handle Q generation, underscoring why targeted adaptation is needed. Okay, this grouped bar chart shows how reinforcement learning changed accuracy across the QN 2.5 family. Look first at the full panel to see pass at 1 through pass at 16, plus overall solved rate per model size. Building on the earlier results, gains grow steadily with scale. The 14B improves, and the 32B climbs highest. Next, compare the standard versus reasoning variants on the right. The reasoning bars are consistently taller, indicating better outcomes when the largest models are trained to reason explicitly. Building on those results, 2 takeaways stand out. First, a full-stack recipe that combines domain pre-training, supervised fine-tuning, and reinforcement learning can flip the leaderboard on a low-resource language like Q. Second, careful evaluation prevents reward hacking. Reinforcement learning means training with test-based rewards to refine behavior. I am Alex, thanks for listening.